Welcome to Precalculus. In this set of videos, we are going to be exploring polynomial division. Now, a lot of us feel that division is where we lost track of math and started to hate things. Because long division follows a very set process and it can feel very strange as we go through it, and who knows what division means anyways. Well, division at its heart represents dividing things into different parts of equal size. And for polynomial division, it's less clear because we're dividing it into something of an unknown size. In a sense, we should think of division more so as factoring. By dividing something into parts, we are separating it into its different factors. Ultimately, we will learn how to use division to factor polynomials, but before we can get there, we have to establish what division is and how to do it. So we've got an example here, x to the fifth power minus 3 times x to the fourth plus 2x squared minus x plus 5 divided by x squared plus 2. Now you'll notice that both of these are polynomials. They are sums and differences of powers of x. So we can set this up like we would any type of division. So I'll have my divisor, that's the part I'm dividing by, and my dividend, which is the part that is being divided. So that's x to the fifth minus 3x to the fourth. But notice there isn't an x cubed term. I need to be able to line up all my terms vertically. So I have to add 0 times x cubed. It doesn't change the value of what I'm dividing. It just adds a placeholder. Plus 2x squared minus x plus 5. Now, a lot of polynomial division comes down to being able to compare our first terms inside and outside. So our first term on the outside is x squared, and the inside term is x to the fifth. So in order to do this, I'm going to look at what do I need to multiply by x squared to get x to the fifth. In a sense, we are looking at what two factors give me x to the fifth if I know one of the factors is x squared. So we can divide both sides by x squared. So our question mark here is x cubed. So I'm going to write this x cubed over the space for x cubed because I said I want all of my factors to line up vertically. And I'm going to erase this work here. And the next step is to multiply the divisor by what we just wrote down. So x squared times x cubed is x to the fifth. And then 2 times x cubed is 2x cubed. And again, I'm lining it up with the factor above. Now, once we've done this multiplying, we have to subtract. So since there are two terms, I'm going to subtract each of them. And so x to the fifth minus x to the fifth, these just cancel out, and we get 0. And then we carry down negative 3x to the fourth, and we add 0 plus negative 2 gives us negative 2x cubed. And now we can carry down everything else that remains in the dividend. And repeat this process with our new first term. What do I need to multiply x squared by to get negative 3x to the fourth? Take a moment, pause the video, and think, what do I need to multiply x squared by to get negative 3 times x to the fourth? Now, if you've been thinking we need to multiply it by negative 3 times x squared, you would be correct. So then we multiply, get negative 3x squared to the fourth minus 6x squared. Now, I've noticed I've made a mistake. So pause the video, look at the work, and see if you can identify what mistake I've made. Exactly. I wrote this under the wrong column. I need to write it under the column for the squares. So negative 6x squared. And now I'm going to subtract each of these. When I subtract a negative number, note that it turns into a positive number. So I'll have positive 3x to the fourth and positive 6. So once again, these cancel out. I carry down negative 2x cubed, and then 2 plus 6 is 8x squared minus x plus 5. Now I'm getting close to how far down the screen you can see, so soon I'll have to erase some of this work, but we're going to continue repeating the same process. And right now, I need to figure out what do I multiply x squared by to get negative 2x cubed. And as you might have thought, all I need to do is multiply it by negative 2x. So minus 2x. So then I have negative 2x cubed plus 4x squared. Nope, I made that same mistake again. Which is why a lot of people dislike division. There's a lot of easy places where if we're not paying enough attention, we can make common mistakes. And so being aware consciously of what we're doing and where we're placing things helps us avoid those mistakes and feel more confident doing polynomial division. So 2 times negative 2x is negative 4x. And then, let's see, let me try to write that up just a little bit higher. All right, so these cancel out. We have 8x squared, just barely see that, minus 5x plus 5. What I'm going to do is I'm going to erase the work that we've got. And then I'm going to put up here 8x squared minus 5x plus 5 so that we can see exactly the work that we were up to. So now, what can I multiply x squared by to get 8x squared? Well, that one's the simplest. It's just 8. So plus 8. So we'll have 8x squared, and then 2 times 8 is 16. See, making sure I've got it under that constant term. And now we subtract. So we get 0 for the first one, and then negative 5x. 5 minus 16 is negative 11. And so now we have a few different ways of writing our answer. And I say writing our answer because there's nothing I can multiply x squared by to get x. So once we get to this constant column, everything else must be a remainder. So our quotient is x cubed minus 3x squared minus 2x plus 8 with a remainder of negative 5x minus 11. Now, that's one way that we could write our answer, but there is another way that we could write our answer. We could instead show that we are adding the remainder. So we could have plus negative, let's see, it was negative 5x minus 11. So we're adding this, so we divide it by what we're dividing by, x squared plus 2. So it's what remained at the end, divided by what we were initially dividing by. Now, notice that we have 2 negative signs there. If we wanted to, we could factor out a negative sign and put subtracting the remainder, since the remainder was itself negative. Either one is perfectly acceptable. I think most of us would just leave it right here. And so this has been an example of polynomial long division. As you can see, we were able to divide one polynomial by another. When we are dividing by polynomials with long division, it doesn't matter what our exponents are, it doesn't matter what our coefficients are, as long as we can power through and keep track of all those little places where it's easy to make mistakes, we'll be able to successfully divide our polynomials.